Hello everybody, today we'll be doing permutations in string. Given two strings, S1 and S2, return true if S2 contains a permutation of S1, or false otherwise. In other words, return true if one of S1's permutations is the substring of S2. So S1 is AB. Do we see an AB in S1? And we do. We see two items, B and A, and we could return that. If we look for AB, there are no spaces where AB is possible. Now, edge cases that we're going to look at are probably like, what if SS1 is empty? And the answer to that is, well, if S1 is empty, should we return true? But that's not possible because it is a single character. So we have to seek for that single character. So minimum input is S1 is equal to A, and we have to check in S2 if there is an A. And there is. We have A right here. So that's our edge case. So what's our time and space complexity for this? What do you think? I think that we're going to look for S1 and S2 in every slot. So it's going to take S2 time, so O of n, or m for S2, length of S2. Yeah, that's the maximum because S1 might be a single character and we might be checking single characters. Otherwise, the minimum time would be O of m minus n because we will only need to check two spaces at once. So basically, we stop checking right here. This is our last check if n for length of S1. Otherwise, and for space, in terms of space, we're just returning a true or false. So, and we're using pointers. So I think it's O of 1 space. With that, I think we're starting to get a match here, and the match is going to be just pointers. And let's talk about plan. So create pointer to, what we're gonna do is iterate in terms of 1 m minus n to get all possible permutations. Yeah. So what we're gonna use a hash map to get num characters in window. So we have to do a sliding window basically. Because what we're trying to do here is take a look at this example, is that we're trying to create a window at where we can insert our items, and in this window we will start reducing and increasing the item once we have gone to that window. Yeah, essentially, yes. And if the hash map is equal to S1 hash map, if the permutation hash map is equal to S1 hash map, then return true. Else we reach the end, m minus n, then we just quit. Then we quit and return false. And with that, I think we have a plan. It's pretty solid. I think we can start implementing now, and let's get started. So first things first, let's get a hash map of S1 to find out how many characters of the characters. So counter S1 count equals counter of S1. Perfect. Now, what we're going to do for S2 is we create I pointer. I equals 0. And we're going to go into, well, let's get M and N. So N, N, M, and N equals S length of S2 and equals length of S1. So while I is equal to 0, let's get the first n items into our hash map, and then we'll move forward with that. So S permutation counter is equal to the counter of S2 from the start until M. No, N, yes. The problem with that is that if S2 is shorter than S1, then we have an issue because we need to make sure that S1, if M is less than N, then return false immediately, because in that case there's no computation that needs to be done, because it can't be done. There's no permutation that's possible. So that is an edge case. So let's type that in as well now that we've thought about it. So let's swap that. And we're looking for this permutation, and our S is shorter. That's impossible. So we're gonna output is gonna be false. And with that, let's clean that up a little bit. So now this is possible. Now we have two permutation counters. So we're gonna start by I at 0. Or we can just do a for loop for I in range of M minus N. So we're going to go from M minus N. So that's our distance that we're going to travel. And we're going to lose, I items. We're going to do I plus N. So I plus N is the item that we're going to add to our counter. So first things first, if S1 count is equal to permutation counter, then return true. Otherwise, we're going to lose an item, then add an item. Okay, so basically, perm counter at the string 2 at I minus equals 1, and then the perm count is going to increase plus N is going to plus equals 1 if it exists. If it doesn't exist, then we'll have to, if S of 2 I plus N in counter, perm counter, plus equals 1, else this is going to be equal to 1. So with that, we are able to get all of this done. The one thing that I am cognizant about is that we are adding the same item. No, we're not. No, we are. We definitely are. No, we're not. Because this goes up until N, this becomes N, right? And so we subtract the first item and we add the second item, the next item. Makes sense. Makes sense. Okay, with that, let's try this code out and make sure that we are getting what we want to get. So we have I here. We have n is going to be equal to length of 2. So 0, 1, 2. So this is n. And so what we're going to do here is that we're going to subtract e equals 1. And we had I equals 1. And we're going to subtract the e. That's going to be 0. And we're going to have d is equal to d is equal to 1. And that's not equal, right? So we're going to keep moving forward. And now we're going to lose the I. And we're going to add the B. And then that's not going to be 0. So we're going to lose the D. And add the A. So it's going to be B and A. That was what we found. But if we're trying to get like B, A, O, O, let's see what happens. So yeah, that's going to go all the way until the end. So we get B, A, O, O. And we get the same item. And once I is m minus n, then we will reach the end. So basically, what is m minus n? M minus n is here, right there. So m is going to be 5. And n is m is the length. M is not going to be 5. It's going to be this item here, which is 8. 8 minus 5. And that's going to be 3. So this is 0, 1, 2, 3. This is perfect. This is the stopping point. Okay, with that, I think we have completed the problem. And let's return false here. Let's run the code. And I think it should work. It might not work. Oh, look, it ran. It was true. Oh no, oh wow, this is crazy. Let's try some of our test cases as well. So here we go. We have, this is our test case. Let's swap that around. And we have A, B here. And that should return false. And let's get that last thing we tested. A, B, O, O, O. Let's see if we get that. Oh, we returned false. That's not true. That's not good. I think it's because we ended a little bit too early. So we need to do a +1 here. Perfect. I knew that there was a +1 here because we needed to reach the end. And with that, I think we're ready to submit. Let's see what happens and let's see what sort of errors we can get. I think that's important to find out. And we are out of range. Check that out. So S of I plus n is out of range in the perm counter. And that's not good. So that's not something that we should do. So how are we going to do this if we can't get this done? So I think it has something to do with the check and the balance. So give me some time. I'm going to go figure this out. Okay, I think it was the last check that I missed because of this. As I said, it was because of this was checked before this was done. And so let's submit this again. And I think it should work this time. Perfect. And if we wanted to take care of this properly and remove this statement, we would have to do the check, our first check like this. and then shift everything up. And do our check after the count. So that's another way to do it. It might be cleaner. I don't know. But the evaluation is the same. So evaluate is going to be O of n, because we just go through all string, m minus n, as you can see this range here. And the space is actually O of n. So because we take up the length of S1 being the length of S1. So let's try to clean up this code a little bit more, and I'll be back. So I did clean up the code a little bit more. It is more condensed now. It looks a little bit cleaner. What we have here is getting the length, and then we have an if statement that tells us if m and n is less than n, that means it's always going to be false. So we return that, taking care of that edge case. We create two counters, and we checked if they're equal first, and then we started updating by losing the first item and adding on the last item with our sliding window. And with that, we can return true, and we return false if nothing's found. The idea, that the one thing is that the question I can ask is, can we get this in, this check, into this for loop? And I think we can, actually. The way we do that is that we start at -1. We start at we can start at -1. So how does that work? So if we start at -1, we can say if I is equal to -1, then do this, else we do this. And we can definitely do it. So let's try it. So we start at -1. Okay, so if I is greater than 0, then we'll add, and we can do this if statement, and we lose this if statement. I don't know if that looks any cleaner, or it just makes everything more like wacky. I'm not sure, but let's run it. It should work. Oh, sorry about that. That's a comma. I don't know if this code makes it cleaner or worse, or oh, it's returning false now. That's weird. Oh, it's greater than or equal to 0. Sorry about that. So I think that's the one that we were missing. Let's submit now and check that out. So that was one way to get around that statement, but we had to add another statement here just in case, because we don't want to mess with -1. Yeah, and that's about it that we could do. So yeah, interesting stuff. And I don't know if we can make this code more readable. Does this make it more readable? I think it does, because people would wonder why we have a -1 here and why we have an I plus equals is greater than or equal to 0. So people would think about this loop a little bit more compared to why are we checking it immediately and checking it later. Yeah, I think this makes a little bit more sense. Anyways, with that, I hope you enjoyed this video. Like and subscribe. And if you have better code, please comment below with your code, and let's all learn together. Thank you. Bye.